Alright guys, hey, we're going to quickly look at non-proportional relationships. Remember, it's your responsibility to be able to show or represent non-proportional linear situations in the forms of graph, tables, and equations. So we're going to quickly just go over what's proportional and non-proportional, and then look at a couple examples, and look at some equations, and fill in a table, and then take a table and be able to write an equation the other way. So we're going to be able to represent or show that. So proportional versus non-proportional. So remember what we talked about so far. In order for something to be proportional, it must go through the origin. It must have a constant rate of change. So non-proportional means it does not go through the origin, but it does still have a constant rate of change. So let's look at these two top graphs. You notice here in the graph, a linear line, straight line, so it's linear, and it goes through the origin. Whereas the non-proportional one is linear, so it has a constant rate of change, but it does not go through the origin. Where this line intersects the y-axis is what we call the y-intercept. When we write our equations, this equation would be represented as y equals mx, whereas this one would be y equals mx plus b, b being our y-intercept. Two tables. So you notice this table here starts at the origin, 0, 0, has a constant rate of change. When x goes up 1, y goes up 4. So constant rate of change. Here y equals mx plus b, so you notice this does not go through the origin. This would be our y-intercept. The value of y when x is 0. So if this was to be plotted, right here this would be 1. This is where it would be on the y-intercept. So you notice here it does have a constant rate of change. Goes up 4, goes up 4, goes up 4, goes up 1, goes up 1, goes up 1. So every time x goes up 1, y is going up 4. So you'd see y equals 4x plus 1. The 1 being where we began, the 4 representing the rate of change. Alright. So slope and y-intercept of a non-proportional equation. So this is my equation, y equals mx plus b. The m is the slope, right? That's our rate of change. The b is our y-intercept. So let's see if we can find the y-intercept and the slope of these three equations. Y equals 2/3 x plus b. I'm going to use the blue to circle my slopes. So you see here, m is the slope, it's the value next to the x. So the value next to the x here is 2/3. So my slope is 2/3. On this one, the value next to the x is a -3. So my slope is a -3. And then here, we have the value 4 next to my x, so my slope is 4. I'm going to use red for my y-intercept. So this is the y-intercept, our b. It's where the value of y when x is 0. So it's right after the plus sign, so we have 9. We have, this one you see is a -7. So if it's in the form of y equals mx plus b, we have a positive y-intercept. If it's in the form of y equals mx minus b, we're going to have a negative y-intercept. And then this one over here we have 4, so your y-intercept is 4. Okay? So that's how we would find the y-intercept or the slope if given an equation. You would use this information to be able to plot this onto a coordinate plane. And we're going to get to that in the next couple of days. All right. Using the equation to complete a table. So y equals 4x plus 7. We said that this 7 represents the what? The y-intercept. The value of y when x is 0. So when x is 0, y is 7. When x is 0, y is 7. Now, we got to find the rate of change. Well, where is the rate of change or the slope in the equation? Very good. The 4 is the rate of change. So this is 4/1. Remember, slope is written as y over x. So the 4 is represented by the y. The x is represented by the 1. So every time x goes up 1, how many does y go up? 4. So when x goes up 1, y goes up 4 to 11. Goes up 1, goes up 4 to 15. Goes up 1, 19. Goes up 1, 23. Goes up 1, 27. Y equals 4x plus 7. Now, How do I find the slope in the y-intercept if I'm giving the table and I need to write the equation? Well, I know that the y-intercept, my b, is the value of y when x is 0. So x is 0. So my y-intercept is -4. I need to find my m, and I need to find my b. Well, my b is -4. Y equals mx plus a -4. Well, I need to find my slope. That's my rate of change. So x is going up 1. Y over x. So when x goes up 1, how many is y going up? Well, -4 to 2 is 6. 2 to 8 is 6. 8 to 14 is 6. 14 to 20 is 6. So y is going up 6 every time x goes up 1. So our slope is 6 over 1, or simply 6. So y equals 6x minus 4. Alright, that would be my equation, the slope and the y-intercept, and slope. One more. So again, I'm writing it in the form of y equals mx plus b. I need to find my b. I need to find my m. So again, the y-intercept is the value of y when x is 0. So x 0, y 11. So my b is 11. And my slope is my rate of change. When x changes, how much does y change? So again, x here is changing by 1. Well, we have y over x. X is changing by 1. How many is y changing by? That's going by 3. Changes by 3, and again by 3. So 3 over 1, or 3, is my slope. So my equation would be y equals 3x plus 11. Alright. Great. And the next day, today and tomorrow, we're going to look at how do I now take this information and put it onto a coordinate plane. And then we're going to look at, if I have a line on a coordinate plane, how do I find the slope and the y-intercept of that line on the coordinate plane, and how do I write the equation? Alright, good luck, guys.